Warm up for lesson 6-3. Pause, and here's the answer. 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 Only B passed the horizontal line test for inverse function. Notice that the horizontal line passed the function in only one spot, so that's a guarantee that when we find the inverse will also be a function. Lesson 6-3, square root functions. Objective, graph and analyze the square root function. There are formulas that describe relationships that have a square root in them. In this case, the pitch of a string is described by a formula that uses the tension, the mass, and the length with a square root function in it. Let's take a look at this square root function. Let's look at the parent function, and notice that it has this special relationship here. We're going to make the domain greater or equal to 0 because we don't want any negative values in there. And notice the y values as x increases. It looks like y is increasing, so this is an increasing function. We see that the intercepts is 0, 0. And let me go to the calculator to show you how to put that in. So we're going to, the square root is right here. So we're going to press second and then x squared. And then you're going to put your x in. And then when you press graph, you'll get this function. Kind of looks like an eyebrow. All right, let's see if we can identify the domain of range of another square root function. What we're going to want to do is we're going to take the part that's inside the square root, which we call the argument, and we're going to set the argument greater or equal to 0 because we don't want it to be negative. And then we solve for x. So our domain is this. You can also write the domain this way. So the lowest value is -4, and it goes to infinity. Now we're going to take this lowest value right here, and we're going to find the y that goes with it. So we have -4. We put -4 back into the function, and that'll be a 0. This is our minimum value. Knowing that this is our minimum value will help us figure out our range. So our range, the smallest y value is 0, and then it goes to infinity. And we can write it in set builder notation, or we can write it in set notation. Let's go ahead and start again. We're going to take the argument, which is x minus 3. We're going to make sure it's greater or equal to 0. So x is greater or equal to 3. We're going to take the smallest x value, which is 3, and we're going to put it back into the function. That's going to be a 0. And this is going to be our minimum value. Now we can go ahead and identify the domain. Our smallest x will be 3, and then it'll go to infinity. For our range, our smallest y value will be 0, and then it'll go to infinity. Let's take a look at this next one. Again, we're going to take the argument, and we're going to ensure that it's greater or equal to 0. So x is greater or equal to -6. So -6 right here will be the smallest x that we're going to use. We're going to put -6 back into the function, and we're going to get 2 as our output. So now we can talk about our domain and range. Our domain will be from -6 to infinity, and our range will be the smallest y value is going to be 2, and that'll go to infinity. Pause, and here's the answer. Let's go ahead and take a look at transformations of square root functions. Very similar to what we did with a parabola. Remember, with a parabola, our parent function was y equal to x squared, and then we looked at translations that were in what we call vertex form, and it showed us how the vertex was moving so that we could graph it easily. Well, we're doing the same thing. Our parent is y is equal to root x, And very similar to the vertex form, this tells us how to move our minimum point. H will represent a horizontal translation, K will represent a vertical translation, and A will, very similar to this, will give our orientation and shape. So when it's less than 0, negative, it'll be a reflection over across the x-axis. If A is greater than 0, it's going to be a stretch vertically, and if it's between 0 and 1, it's compression. Let's take a look at this function. Okay, and I have the standard form right here. Okay, so we can go ahead and use the standard form here. We're going to take the argument, and we're going to make sure it's greater or equal to 0. So x is greater or equal to 2. So we know our minimum value is going to be 2. Put 2 back into the function and you're going to get a 5. And that's what they're saying right here. Here's our function. You can just read it right here. All right, so this is our minimum point, 2, 5. Now, what we can do here is, remember our original function, our parent function, looked like this. So what we're doing is really taking this minimum value, going over 2 units and up 5 units, instead of going through this process that we have done to the previous problems. Now our domain, we can write it as 2 to infinity, and our range, remember our lowest y value is 5 to infinity. So you can write it in set builder notation, or you can write it in interval notation. Let's take a look at another one, and let's go ahead and just rely on this and take a look at our HK. Now if I rewrite this problem like with a subtraction in it, then this will be x take away a -3 minus 1. And now we can read our HK a lot better. Our H will be -3 and our K will be -1, which is what's happening right here. -3, -1. Now our A is -2. -2 means there's going to be a reflection. So what normally would have been going up right here, now we're going to be a decreasing function, and it's going to go this way. So there's a reflection. So our domain is going to be -3 to infinity, and our range will be our highest y value. So I need to erase that. So our highest y value is going to be -1, and we're going to go from -infinity, low y values, up to this highest y value. Okay, let's go ahead and start from scratch and see what we can do. I am going to rewrite this in standard notation. And now I can read my HK. So my H will be -4. And if I put -4 back into here, I'm going to get a 0. So I have an inkling of what the graph looks like. Normally the parent function looks like this. And so what this is telling me is it's going to start here at -4, 0, and it's going to have a little bit of a vertical stretch like this. And my domain will be -4 to infinity, and my range, the lowest y value, is 0 to infinity. Let's take a look at this one, and it's already in my HK form, so I can read my HK. My HK will be 5. Put a 5 back in here, and that'll be 3. So I know I'm going to go over 5 units and up 3 units, and my A is positive, and this is a compression, so it's barely going to grow, but it's going to grow like that. And this is the point 5, 3. All right, and so my domain will be from 5 to infinity, and my range will be, the lowest y value is 3 to infinity. Pause, and here's the answer. You can do it with the HK method, or you can do it with just finding the minimum and then going from there. Pause, and here's the answer. You can always put it in your calculator if you're not sure about the reflection.